Hi, good morning students. Let us continue our topic. Today I am going to discuss about the working of full wave rectifier. 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 Now let us see how this rectifies AC as a DC. Let us discuss. Working of full wave rectifier. Now let us take a diagram. We know what is this. This is a transformer primary coil, and this is a secondary coil of a transformer, and we are drawing two lines here, which represents the primary coil of a transformer, and this is the secondary coil of a transformer. Here the same, the AC input, here we are giving the AC input to the primary coil. This is AC input, we are giving AC here. Here we are using two diodes, instead of one diode we are using two diodes. Let it be diode 1, and here it is diode 2. This is P type and this is N type, this is P type and this is N type. These two are connected like this. Here we are center tapping. See, center tapping means we are connected a wire to the ground. What is mean by that here? This represents the ground. The wire is connected to the ground. This is called, C means is a center tapping. Center tapping transformer. What is the purpose of this center tapping? Why you are connected a single wire from the secondary coil to the ground means at any instant of time one diode is in forward bias and another diode is in reverse bias. For this purpose we are center tapping. For this purpose here we are center tapping. Now you can take the output. DC output, here it is same. From load resistance, this is a load resistor, and we get DC output. DC output. This is our circuit diagram. Again I can explain. The AC input signal is given to the primary coil, here it is, and this is induced to the secondary coil. Here we are using two diodes. Here using two diodes. Why? Because in a half wave rectifier we are using only single diode. For that single diode, just half of the wave is rectified. So that to avoid that, to rectify full wave, we are using two diodes. And here one more difference is the transformer is the center tap transformer. Why here we are center tap? Due to that center tapping, at any instant of time, one diode is in forward bias and another diode is in reverse bias for this purpose. So here what is it represents? It represents a ground which is connected to the ground. These lines are represents to ground. And the DC output as usual taken from load resistance RL. Taken from load resistance RL. Okay. Next, how it works? Let us see. First, we'll see the output wave. This is like this. This is our AC input. This is the AC input. This is AC input. Here we want DC output. Now let us see what happened. How it converts. This is a positive half cycle, negative, positive, negative, positive, negative, positive, negative, positive, negative. Got it? So what happens? First, let us see. First here the positive half cycle is started here and then it goes to here like this. During the positive half cycle of AC, diode D is in forward bias and D2 is in reverse bias. So the current passes through diode D1 only. I can like this. D1 means the output is due to D1. During negative half cycles of AC, diode D1 is in reverse bias, D2 is in forward bias, and current passes through D2 only. So we will get the D2 like this. So D1 for positive half cycles and D2 for negative half cycles. This is the D1 and this is the D2. D1 and this is D2. Got it? We will get the full wave rectifier as a DC. This is a continuous also. In a half wave rectifier, due to that half wave rectifier, it is a discontinuous, and here it is a continuous waveform. Here it is continuous waveform. Okay, got it? Now let us see. Take a note first. The first point is full wave rectifier is constructed with two diodes D1 and D2. D1 and D2. Second point. The AC input signal is given to the primary coil of a transformer and it is induced to the secondary coil. Here the secondary transformer is a center trap transformer, so that at any instant of time one diode is in forward bias and another diode is in reverse bias. So through the diodes the DC output can be taken across the load resistance. And the third point. During positive half cycles of AC, all positive cycles of AC, diode D1 is in forward bias and D2 is in reverse bias. What happens? The current passes through D1 and we get the output D1, 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 D1 as a DC. During negative half cycles of AC, diode D1 is in reverse bias and D2 is in forward bias. So the current passes through D2. Current passes through D2. So we can have D2. So by using these two diodes in a half wave rectifier, we used only single diode, so that half wave only rectified. But to avoid that, we are using two diodes in the full wave rectifier, so the full wave is rectified. That is the reason why we have full wave rectifier used. So here also says efficiency, formula for the efficiency. We can write the formula for the efficiency. Efficiency is equals to same DC power output by AC power input, PDC by PAC, and the formula for efficiency eta is equals to 0.812 into RL by RL plus RF, where we know what is RL. RL is equals to load resistance, RF is equals to forward resistance of diode, forward resistance of diode. Here look at here the expression. Here we have the value 0.812. As this value is a double for the half wave, in the case of half wave rectifier it is 0.406, which is multiplied by 2, we can get this one. Means the ripple for the half wave rectifier is n heads, the ripple for the full wave rectifier is 2n, it becomes double. In the half wave rectifier just you are having 0.406, but in the case of full wave rectifier you are having 0.812, you have to remember. The half wave rectifier is multiplied with 2 efficiency, then we can get this. So this is, now once again listen here carefully, I can explain again. So full wave rectifier is constructed with two diodes. The AC input signal is given to the primary coil of a transformer and it is induced to the secondary coil. Here the secondary coil is the center trap transformer, so that at any instant of time one diode is in forward bias and the diode is in reverse bias. Next, during the positive cycles of AC, diode D1 is in forward bias and D2 is in reverse bias. Current passes through D1 only and we can get the output as a DC through the load resistance. During negative half cycles of AC, diode D2 is in forward bias and D1 is in reverse bias. Current passes through D2 only and we get the output as a DC through the load resistance. Thus it rectifies full AC wave as a DC and hence it is called full wave rectifier. And the output is continuous. In the case of half wave rectifier, the output is a discontinuous, but here output waveform is continuous wave. So now let us discuss about efficiency. Efficiency means it's the ratio of DC power output for the AC power input, PDC by PAC. And you have to remember the formula efficiency eta is equal to 0.812 into RL by RL plus RF, where RL is the load resistance and RF is the forward resistance of diode. RF is the forward resistance of diode. Now let us see what are the difference